Hello, and welcome back. I'm so excited to see you here. This is the beginning, or it's the first week of 2023, and I'm very happy to see you here. Today, we're going to talk about straight line. I have a few problems for you. They are not complicated, but in order to solve them, you have to understand the few basic things about the straight line problems. There are some things you have to memorize, and I will tell you that in this video. Also, as always, don't forget, if you are interested in doing a credential evaluation, I have a guide that shows you step by step how to do that, and you'll find the guide by clicking the link below. I will send it to your email inbox. Another guide that I have recently prepared, it's called Integral Calculus. It has examples with standard integrals, examples and solutions, I might add, with standard integrals, integration by parts, integration by substitution, and integration by separable variables. So if you also are interested in this guide, click the link below and I will send it to your email inbox. Okay, that being said, let's go ahead and start. What do the following two equations represent? Y equals to 6x minus 2 and 2x minus 12y equals to 24. A, the same line, B, distinct parallel lines, C, perpendicular lines, and D, intersecting but not perpendicular lines. So in order to solve this problem, we must understand what it means for two equations to represent the same line, what it means for two lines to be parallel, perpendicular, and intersecting but not perpendicular. And if you have a little bit of issues understanding this type of problems, I will go straight to the FE handbook, which will be available on the exams. So here we have the general form of the equation. We have the standard form of the equation, which is y equals mx plus b. And we know the m is the slope. And then we have the point slope form, just this. And then the given 2 points, we can calculate the slope. Okay, and we also have the angle between lines with slopes m1 and m2. We can calculate it, and we have this two lines are perpendicular if m1 equals to minus 1 over m2. So we're given here what it means for two lines to be perpendicular, and also the distance between 2 points. So let's go back and go through all of these options. So in order for two equations to represent the same line, obviously the two equations have to be the same. So we're going to have to bring this equation to the same form and see if it's the same equation, then they're going to be the same line. Now, what it means for two lines to be parallel. Two lines are parallel, and it's not given in the FE handbook. This is something that you have to remember. Two lines are parallel if they have the same slope. So if m1 equals to m2, that means those two lines are parallel. Now, perpendicular, when two lines are perpendicular, we're giving in the FE handbook. When m1, the slope of the first equation, is equal to minus 1 over m2, so, and D, intersecting but not perpendicular lines, this will be the case when case C is not satisfied. So let's go ahead and first we'll bring this equation to the same form as this one. I will multiply by 1 over 12. So I get rid of this 12 next to the y. So here I will get 1 over 6x minus y equals to 2. And now let's rearrange it. Okay, so y equals to 1 over 6x minus 2. Okay, now we can see here, let me rewrite the first equation here somewhere as well. So we have y, our first equation is y equals to 6x minus 2. We can see that the first equation, m1, the slope equals to 6, and in second equation, m2 equals to 1 over 6. So first of all, we can see right away these two equations are not the same because the slopes are different, even though we have the same y-intercept, 2, minus 2. These equations are not the same, so we're just going to cross this out. And now we can also see m1 equals to 6, m2 equals to 1 over 6. So they don't have the same slope. So these two lines are not parallel either. Now we have to move farther and check if these two lines are perpendicular. And in the FE handbook, you were told that two lines are perpendicular when m1 equals to the negative inverse of m2. So let's go ahead and substitute here and find out if it is true or not. So 6 equals to minus 1 over 6. And move forward, we're going to have 6 equals to minus 1. And we do multiply by inverse. So that's 6 over 1. And this will be equal to 6 equals 2 minus 6. And this is not true. So this means that these two lines are not perpendicular. So the only case remaining is that these two lines intersect, but they're not perpendicular. And this is the correct answer. Find the minimum distance between the point minus 3, 2, and the line y equals to minus x plus 1. So first, we have to understand what is the minimum distance between the point and the line. And of course, this is the distance that falls perpendicular to this line, right? That's the smallest distance. Okay, so in order to, if you think about it, in order to solve this, this point will intersect this line in another point. And this is, if we elongate it, this is actually another line, right, that goes through these 2 points. So let's think about it. How do we approach this problem? So we have this point here, minus 3, 2. And we have the equation of this line here. If I am going to rewrite this minus x plus 1, this means that m1 equals to minus 1. And let me write the equation of this second line that I showed here, that goes through this point minus 3, 2 and intersects this line. I'm going to write so this is L1. This is L2. So y is going to be equal m2 x plus b. This is the general form of the second line here. L2, and this is L1. So we know that the minimum distance is going to fall perpendicular to L1. And when two lines are perpendicular, we've already saw that in the first problem we solved. And this is given also in the FE handbook. Two lines are perpendicular when the slope of the first line equals to the negative inverse of the second line slope. So let's go ahead, since we have the slope of the first line, we can calculate the slope of our second line. So we'll just go ahead and do that. So m1 equals to minus 1. Or you know what, maybe this is not shown quite right here. I'll just say m2 equals, and let me calculate it here below. We know that L1 is perpendicular to L2 if m1 equals to negative inverse of m2. And let's go ahead and do that. We will substitute m1 is minus 1 equals 2 minus 1 over m2. And from here, we are going to take m2 equals 2 minus 1 over minus 1. So this means m2 equals to 1. So we have just calculated the slope of the second line, and let's just write the equation. And so m2 here, I'll put 1. So L2 is going to look like that. Y equals 2. So m2 is 1. I'm going to just write x plus b. So let's calculate b now. How do we calculate b? We know that the second line goes through the point minus 3, 2. So this means that this point has to satisfy this equation. So we are going to just substitute y and x in this equation here, and this is the way we're going to find b. So we have 2 equals 2 minus 3 plus b. And from this equation, very easily, you can see that b is equal to 5. All right, so we can rewrite again our equation now. Will look like this. X plus 5. This is the equation of the second line. And now we have these two equations of L1 and L2. In order for us to calculate this distance, we have to calculate the point where these two lines intersect. In order to find where these two lines intersect, we just have to take y1 equals to y2. So this will be equal to minus x plus 1 equals to x plus 5. And from here, we are going to get minus 2x equals to 4. And from here, we find that x equals to minus 2. So we found that x equals to minus 2, and if we go back into any of these equations, we will find y. I'll just go here in line 2, where y is equal to x plus 5, and if we substitute, we'll get minus 2 plus 5. Let me just look at this. Minus 2 plus 5 equals to 3. So this means y equals to 3. So what we just found is x and y is the point where these two lines intersect. So I can write right here minus 2, 3. And of course, if you look at the graph, it matches exactly what we just have calculated, minus 2, 3. The way we did that, in order to find where two lines intersect, we have the two equations and we set them equal. And this way we find x, and then you go back to any of those equations and substitute x and you find y. So from here is pretty simple. We have 2 points and we have to find the distance. And the formula here in the FE handbook, the distance between 2 points is y2 minus y1 squared plus x2 minus x1 squared. And we're going to go back here and we're going to calculate where do I do this. So let me do this here. Distance equals to y2 minus y1 squared plus x2 minus x1 squared, and this equals 2. So we can set any of this as y2 or y1, it doesn't matter because we have it if we get a negative number, we're just going to have it as squared. Let me just, I'll take this as y2, the point we just found. So 3 minus 2 is 1. So 3 minus 2 squared plus minus 2 minus minus 3. That's going to be plus 3 squared. And we get 3 minus 1. Sorry, 3 minus 2 here. It's 3 minus 2, right? 3 minus 2, and I just wrote 1. So we have 1 squared plus minus 2 plus 3 is 1 as well. So we have 1 squared plus 1 squared. We have 2. So the distance between this point and the line, the minimum distance, is square root of 2. And the correct answer is A. Another thing I just want to point out here is that, let's say you didn't know this formula here, the distance, right? We have this point minus 3, 2, and this point minus 2, 3 that we have just calculated. And if you think about it, let's see, what is the horizontal distance between these 2 points? What is this horizontal distance? We can see here clearly that this distance is y. And what is the vertical distance between these 2 points? Again, clearly here, this distance is y. So in order for us to calculate the distance from minus 3, 2 point to this new point, it's nothing else than Pythagorean theorem, right? We have this distance equals to square root of 1 squared plus 1 squared. And it's exactly this thing over here. It's just something to keep in mind in case you get confused on the exam. All it is, Pythagorean theorem. And you get the same result, square root of 2, obviously, answer A. Problem number 3, write the equation of a line that is parallel to the line y equals to minus 3 over 2 x minus 1, and that passes through the point 4, 6. Okay, so we have to write the equation of a line that is parallel to the line y, and it passes through the point 4, 6. Okay, so what do we know about 2 lines being parallel? We've discussed this in the first problem. 2 lines are parallel, right? If we just write L1 is parallel to L2 if the slope of line 1 is equal to the slope of line 2. So this is something you are not given in the FE handbook, but it's easy to remember. 2 lines are parallel if their slopes are equal. So we have the slope of line 1. We have M1 given in the problem. M1 equals to minus 3 over 2. And if you look at this, your equation has to look something like this. Minus 3 over 2x plus b. This is how your equation has to look like. And by looking at this, you already can eliminate a and b, right? The only option for you will be c and d. So what we must calculate now, we have to calculate this b-intercept. So we know, write the equation of a line that is parallel to this line and that passes through the point 4, 6. Now, we know that if this line passes through this point 4, 6, that means that this point has to satisfy this equation over here. So we're just going to go ahead and substitute, and we'll have y, which is 6, equals to minus 3 over 2 multiplied by 4 plus b. And from here, let me just do this, 2. From here, b is going to be equal to, we get minus 6 going on the other side. We're going to have plus 6, 12. So let's rewrite our equation. Y will be equal to minus 3 over 2 plus 12. So this is the equation of a line that is parallel to this line given in the problem, and that passes through the point 4, 6. And the correct answer is D. So remember, the only thing we did here, we had to know when two lines are parallel. We found easily the slope of the second line. And since we know that this line passes through the point 4, 6, we know that this point 4, 6 has to satisfy this equation. So the only thing moving forward we did is just substitute x and y in this equation, and we found B. Problem number 4. One line passes through the points -7, -4, and 5, 4. Another line passes through points -4, 6, and 6, -9. Are these lines parallel, perpendicular, intersecting but not perpendicular lines, the same line? So again, we've discussed, we already know when two lines are parallel, perpendicular, when two lines are the same, and when they are intersect but not perpendicular. If we want, we can represent these points into this graph. And I will do that just to have a visual of it. So we've got -7, -4. So this is my first point. And then we have 5, 4, 5, 4. And this is the next point. And I will try and draw a line that goes through these 2 points. And then another line passes through points -4, 6, -4, 6, and 6, -9. 6, and then go -9. So let's see, where is 9? This is -1, 2, 3, 4, 5, 7, 8, 9. So this is 9. Okay, so if I go through these 2 points like that. So these 2 lines, they look perpendicular. Let's see, how can we prove this by using the straight line formulas? So we know when 2 lines are perpendicular, M1, and this is given in the FE handbook, negative inverse of M2. If you were to say you don't have time on the exam and you have to do this quickly, you can exclude the fact that these 2 lines, you know, they are not parallel based on our visual analysis here, and it's not the same line. So the only thing left is B and C. Okay, so let's see. I'm gonna go back here to FE handbook and see what can I do here. So I'm given 2 points, and I can calculate the slope. So let's go ahead and use this, where we're giving 2 points, and we can calculate the slope of the line 1 and slope of line 2. It's as easy as that. Let's do this. M1 is going to be equal to, the formula says, x at y2 minus n y1, x2 minus x1. And let's substitute. We'll have 4 minus 4, I get +4, 5 minus 7 plus 7, and this is equal to 8/12. And if we reduce by 4, we get 2 and 3. So the slope of the first line is 2/3. Let's go ahead and calculate the slope of the second line. -9 minus 6 over 6 minus 4, I get +4. So here, so we have -15 here at the top over 10. So if we reduce this by 5, we get 3 and we get 2. So the answer here is 3/2. -3/2, excuse me. We don't want to forget the minus, it's very important. So now let's see if M1 equals to -1/M2. In order for L1 to be perpendicular to L2, we should have this condition. The slope of M1 has to be equal to the negative inverse of slope 2. So we have minus 3/2 here. And this means that 2/3 is equal to, I'll do -1, multiplied by, in our case, minus 2/3. So this comes up to 2/3 equals 2, and minus with minus gets us to positive. So we have 2/3 is equal to 2/3, and this is true. What we have just found is that these two lines satisfy this condition, which means that they are perpendicular indeed. So the correct answer is B. These two lines are perpendicular. And let's go to the next problem. Find the minimum distance between the point 2, -1 and the line y equals to 7. You're probably noticing right away that the equation of this line, y equals to 7, it looks a little bit bizarre, right? It's not the form that you are used to. And let's see, what does this mean? If we have y equals to 7, so we go here to the graph, we have y equals to 7. So what this means is that this line is going through the point 7, or intersects the y at point 7 and is parallel to the x-axis. So this is line y equals to 7. And we have to find the minimum distance between this line and the point 2 minus 1. Let's go ahead and find this point 2 minus 1. It's going to be here. And the minimum distance between this point and the line, we know it's the distance that falls perpendicular to the line. So in our case, the minimum distance is going to be from this point straight up. So this line that I just drew, I'm going to continue it here. It's going to intersect our line y equals to 7. And maybe I should do that this is L1. And I'm going to do this is L2. It has to intersect the L1 into this point, which will form a 90-degree angle here. So this is something similar to what we have done before. And right here, you can tell right away the distance is going to be 8. But how can we prove this using the algebraic equations or the straight line equations? Let's analyze this a little bit. So we know that since this line is parallel to the y-axis, and we have this point that goes straight up, it has to be perpendicular to this line that is parallel to the x-axis. What we know is that the coordinate of this point here is going to have the same x as this point here. So we know that the coordinate of this point is going to be, the x coordinate of this point is going to be 2. Let me try and use a different color just for, let me try and use red. I'm going to use this just to make things clear. So we know that the coordinate of this point here, the x coordinate, right? And this comes from the fact that this line L1 is parallel to the x-axis, and we have to find the minimum distance between this point here to this parallel line. And this means that this point over here is going to have the same x as this point here. So we know this, our new point, it's going to look like this. 2 something else. And then what is something else? Obviously, something else is 7. The y component is 7 because this is the line that is parallel to x-axis and goes through point 7, intersects the y-axis in point 7. So we have just found our new point, or the point where this line L2 intersects L1. So now what we have here, we have 2 points, and we know how to calculate the distance between 2 points. y2 minus y1 squared plus x2 minus x1 squared, y2 minus y1. So we have, again, either of these points can be 0.1 and either of them can be 0.2. It doesn't matter. So let's say this is my 0.1 and this is 2, but it can be any other way, right? You can choose the other way around. So we have minus 1 minus 7 squared plus, and our x's are the same, 2 minus 2 squared equals 2. And we have here minus 1 is minus 8 squared, 64. So the result that the distance between the 2 points is 8. And the correct answer is 8. Okay, my friends, if you found this video helpful, as always, I'll ask you, don't forget to subscribe and give it a like, because this helps put this video in front of more people just like you. Keep up the good work on practicing the FE problems, and I will see you next week.